Hello, everybody. My name is Valentin Necoară. I'm Chief Technical Officer of CERSign. Maybe you have heard of us. We were mainly focused on digital certificates and cryptography. Basically, if you know us by now, you know us either from certificates from the browsers or from the certificates, qualified certificates from the market in Romania. We are a qualified trust service provider and have a lot of experience in PKI. So basically, security, data security is our business. I'm with CERSign since the start. So we have shifted focus from encrypting, protecting, securing data at rest to securing data in motion. So from a couple of years ago, we moved from straight PKI security to broader cyber security. Some facts about our company. I'm not going to focus on those today. I'm going to focus in the cybersecurity area. We have been a player in a cybersecurity exercise organized by our National Security Agency. We have a couple of years since we are doing that. We can provide and we do services and solutions. We are very active in research and innovation projects. As a historical fact, let's say, we have created our first challenge in 2014, where we have trained our cybercrime division, was called, of CERTRO, in order to become operational. Unfortunately, that team does no longer exist, but it's a good memory. And last but not least, we have been also a long partner for the European Cybersecurity Challenge. This is an event which is focused on the youngsters. It's addressed mainly to high school and the students, and it's a challenge in which the oldest senior must not be over 25 when the contest takes place. And this year, Romania is the proud winner of this competition after being the runner-up for 2 years. CERSign has contributed to this success in organizing the final contest, creating challenges, and also training the Romanian team with our knowledge in cryptography mainly, and with challenges in boot camps. Now, about creating challenges. We have identified as, let's say, big directions to have a vulnerable system, to choose an existing vulnerability and exploit it either in a system or in a, let's say, playground, hiding information in plain sight, create your IoT playground, like we do have a challenge right now in Hacking Village, which is focused on radio frequency and IoT devices. And of course, last but not least, malware and exfiltration. To create a vulnerable system, there are several options. Create your own algorithm and protocol. You must make sure that the protocol is flawed in order to be vulnerable. Yes? Let's say you create a vulnerable symmetric algorithm, like, I don't know, ABC cipher, okay? So we know that the strength of the symmetric algorithm stays in the key and the S boxes. If the design of these two elements is flawed, then the algorithm can be broken. For asymmetric algorithms, The strength lies in the primes or the formulas, and of course size. Size does matter. Too small can be broken. Too large takes too long to compute. So let's say you build your own algorithm, and if you do not calculate exactly the vulnerability and the point where it can be exploited, you may have unpredictable results, like being non-deterministic. You have a symmetric algorithm, you use the same key every time, and you will have different ciphertext. This cannot happen if the input is the same with a symmetric algorithm, the output always should stay the same. Okay? And of course, there is the possibility, and this is what we encountered this year, that you design everything perfectly, but it can be brute forced. This is not good. Now, choosing an existing vulnerability, on the other hand, can be faster. Faster and, let's say, more approachable. There are a lot of vulnerabilities out there. I don't know. How many of you have participated in CTF and solved challenges? Couple. How many of you have created challenges? Okay, so we are the two. Nice one. Let's say it's harder than it looks. So you have a system, software, which you know is vulnerable. There is a vulnerability out there. You can find it on exploit.db, let's say. But you as a creator of the challenge, you must ensure that the challenge is solvable. But some of the vulnerabilities address a specific version of software which runs, let's say, on a specific port. On that port can be, let's say, 5 systems with 5 different vulnerabilities, and the player, does not know exactly which one it is. And running the wrong exploit on a vulnerable software or system can render the system unusable. The hacker does not have the luxury to ask the admin, please reboot my system because my hack shut down. The hacker must wait for a new window of opportunity to run a different exploit. In the CTF, we as challenge creators are focusing to find, let's say, a vulnerability which is, let's say, most of the times, if it doesn't work, it doesn't do anything. So, for instance, in the late vulnerability challenge which we created, we choose RDP. This is one of hackers' favorite because it's used by admins to get control of the user's computer. So you will find it open in lots of networks. And of course, you can find a lot of vulnerability for this in the wild. And worse yet, most of these vulnerabilities are wormable. You can remote execute code. And of course, some exploits are not deterministic. So you can get the shell or you cannot. You can reboot the system, you cannot. This is not this is part of the deal. So basically, an exploit which can do remote execution may not work all the times because, I don't know, on one system there is a software installed which prevents exploiting correctly the vulnerability. Now I'm going to talk about a open SSL Heartbleed. As a hacker, so you find the vulnerable OpenSSL server, and you throw at it data in order to get the key. So you are focused on this vulnerability. I can tell you from our experience that we have tried at least 3 times with hundreds of bits of data in order to get the correct keys from an OpenSSL Heartbleed exploit. So basically, it took us more than 5 days to create a correct capture for a server to be, let's say, identifiable by the players in CTF. And they found this in, I don't know, maybe 2 hours, something like that. So it's a lot of work before the real challenge. As I talked before about the RDP, and I want to address right now the situation when there are vulnerabilities out there. You know that there are vulnerabilities, but it's very difficult, if not impossible, to create a challenge. And I'm going to talk about crack, key reinstallation attack. Probably you've heard about it. So this is a vulnerability. We have tried to make a challenge out of it and failed, and tried several good times, and in the end, we have dropped it. But we'll try harder on the next occasion. This vulnerability, it's at the core of the VPA protocol. So basically, a correct implementation of the protocol would render a system vulnerable. So it's not about misconfiguration, it's not about misimplementation, it's not about anything, let's say, some producer did wrong. It's about some researcher did wrong. Now, the next one, which is my favorite, it's hiding information in plain sight. This is becoming more and more difficult. If you remember, I don't know, let's say 5-6 years ago, phone encryption was something like, okay, it's not even necessary, you can do phone encryption, you can do whole phone encryption, and gradually, right now, we are talking about every phone is encrypted. You need to enter a code to decrypt the phone, stuff like that. Even if you don't enter the code, the phone is still encrypted. So it's very difficult right now to do real cyber forensics when you have cryptography. So sometimes can be even impossible. Steganography, on the other hand, it's, let's say, the best approach to create a challenge. So this is something very common. If a player sees a picture and no other information, he can look, I don't know, in the LSB, if it's an image, or if it's a wave, if there is a payload, if the length of the file is different from the length that would have been with the correct bitrate and stuff like that. So basically, you can hide data in almost anything right now. So everything is data, you can hide anything in it. In order to, for the player to get to the result, you have to leave clues. So if I give you a file, a binary file, a large binary file, and I don't give you anything, you will not know what to do with it. So basically, you will look for entropy, you will see that it's an encrypted file, or if you can look at headers, you can see if it's a memory dump, or it's a movie, or stuff like that. But if I don't give you enough information to say, let's look there, use this password, this is PKCS7 encrypted file, you will not know exactly what you are looking at. And you will take a lot of time guessing about, okay, what does this want from me? So enough clues must be provided, and not too many. So the art here is to find exactly the balance where the clues are making the problem too easy, and there are enough in order to solve the problem. let's say we are talking about the memory dump. And I don't know, key pass. Everybody probably knows what's key pass. In order to, let's say, have difficult passwords, you will store them there and use that tool in order to have them encrypted. But when you mount that image in the memory, yes, key pass may store in his process memory the password. So this was, let's say, one of the challenges that we created. Not every time the password was stored in the memory. So trial and error. In order to make the problem solvable by the users, because if we are talking about AES keys, even if we are talking about 128 bytes, it's still too much. So in order to make the problem solvable, you have to get to the point where the password is in the memory. And furthermore, if we are talking about cryptography, it becomes even more difficult since you must identify the encryption keys and the type of the encryption keys. So there are tools in GitHub is full of them to find the AES keys in memory. So find the AES or bulk extractor. We'll extract everything from memory and you will find some AES keys there. But if you use a different algorithm, like Twofish or Serpent, for that algorithm, there aren't too many tools. So basically, you will want to use that, and you will want to give enough information about, I don't know, the file structure, the data header, in order to convince the player to study the format of the file and identify where exactly in the memory is that key, and not run some Python scripts in order to get everything out. And one more, also one of my favorites, using hidden encrypted volumes. So this is a nice feature of TrueCrypt, right now VeraCrypt, where you can have an encrypted volume and inside of it another encrypted volume. These volumes have different passwords, so a password will open the outer volume, another password the inner volume. Problem is that if you need to put something in the outer volume after you created the hidden volume, there might be a risk to overwrite the hidden volume, and you lose all the data there. So you will not do this at home, but when creating a challenge, you must, let's say, use this capability of this software. And you may override that, and you are back to square one. So we have tried with this challenge 4 or 5 times in order to put enough data before the hidden volume in order not to overwrite it. So another thing, a lot of time, and solving this is a matter of a couple of hours, maybe. Create your own hackable IoT playground, what we have done in the Hacking Village. So this sounds easy, very easy, but it's not. So you need to identify your hardware. Say you want to communicate over radio or Bluetooth or Wi-Fi. Nevertheless, you must find the right hardware. You must find the right IoT intelligent device. We have used here ASP8266, which is very common to anyone. And after you have wired everything, you go to the software. And going to the software means practical programming afterwards, but there's let's say, a specific tool, specific code. So this takes a lot of time. And when you add to all of these ciphers or steganography, the content, which is, let's say, played around between devices, because when you have an IoT challenge, you'll have at least 2 devices communicated between them. So I don't know, even if it's radio, Wi-Fi, or everything, a device will communicate with another device, and your job would be, I don't know, to get what they are communicated, or to make a device disconnect any other devices, or make it think that it's someone else, something like that. And in this area, I can tell you that validation, it's one of the most time-consuming here. When you are validating, you run the whole script, and this is like being data to analog, and then binary data to analog, and then again to digital. You must use the sniffing tools, you must see that the harmonics are correct, you must identify the binary data, you must see that everything was right, and then again go to the drawing board if something is not good. And of course, it's a nice job, but very hard to implement. And for the other part, it's hard even for the players, because there aren't too many tools in this area, in the IoT playground, to reverse engineer, to extract code. You cannot extract AES keys from an image of a flash, ESP8266 flash. And the last one I'm going to talk about right now, it's about malware and exfiltration. This one, it's, let's say, right now, it becomes almost impossible to perform having all the tools at hand. So new antiviruses are, I don't know, even sending to the cloud samples, not working with signature. They are working with behavioral analysis, or even cloud analysis. You can send to Virus Total almost any piece of executable, and that will render you with, I don't know, maybe 80% of the antivirus will say, okay, this is safe, and one will say, this might be wrong because you have anti-debugger in that. And okay, you got caught. So this is difficult to perform unless you have this challenge in a controlled environment. So let's say I'm giving you a network, you don't have internet access, you cannot run other tools, you have some tools on your machine, and your job is to interpret, analyze, and write up your findings based on even dynamic analysis, let's say, without having an antivirus saying you exactly what you need to push further. Exfiltration, of course, can use different protocols. You can analyze traffic, even on DNS is one of the favorites in late time to move data because nobody looks at it. So there is DNSSEC, okay, but how many DNS servers implement that? So there are many ways to exfiltrate data. Building the malware basically will only help the players to understand dynamic analysis of the products besides static analysis, because when you build the code, you build a lot of, let's say, string mangling. You do not say www.google.com. You will say XCWB, whatever. And with some routines, when the code is executed, you will have the string in clear, but the code must be executed. So if you cannot execute because you have a debugger trap, then you go back to the drawing board. However, this kind of software in the latest, let's say așa, are catched by, I don't know, Checkpoint or FireEye, or there are devices, border devices usually, which can intercept that, and this kind of malware will not reach the user. Usually the user must click something and execute something locally which has some kind of payload which is not detected and stuff like that. Basically, for this kind of challenge, the challenge in creating it is that you have created your malware code, and you must reverse engineer it, you must do static analysis, you must do dynamic analysis yourself, because you may find that some guys come with a volatility plugin which can dump everything that you worked for 2 days, let's say. And this is, of course, their merit. If it's their plugin, it's perfect. But from our perspective, it's a lot of work. So as a conclusion, I would say that creating this kind of challenges is very difficult from the technical perspective, what I've presented here, and also finding the idea to construct around it. So, okay, you can take a vulnerability, there are a lot of there, but you must build around it something. You know, there's a story, I don't know, a kind of scenario to construct. And the, let's say, ugliest part is that once you created a challenge and it's in the wild, you cannot use it again. Right now, every challenge that was ever solved, it's solvable by a click. You go to Google, you can find the solver, sometime even the solver there. So this is what I was presenting you today. I thank you. If you have any question, you can find me in the IoT Hacking Village, or I can take them from here if you like. Thank you.
Any questions?
Okay. Sorry.
Hello, thank you for your presentation. I was wondering, why do you want to choose only one vulnerability or not build a real-world case scenario and provide to the user not one but two paths to the getting a shell, a root shell?
So when I say choose a vulnerability, I meant choose an existing vulnerability, but not one. You make a system with existing vulnerabilities. So at the European Cybersecurity Challenge, we have, let's say, isolated network with two systems, each with its vulnerability. So the intended scenario was, let's say, the ACP starvation, and going to this way to the client, and the guy solved it with RAP spoofing. So basically there were two ways, because we didn't cover that.
Let's take another question.
Yeah. Thank you for the presentation. I wanted to ask you, what would you recommend if someone wanted to get into this kind of stuff to solve these DTF challenges, or even to create them like on a smaller scale? What would be the starting point for this?
Let's say the starting point would be to be passionate about some of these fields. So I'm coming from crypto. So basically I've done crypto since everything I'm working. I'm working. So adding crypto to different, let's say, communication protocols or pieces of software was like a natural addition. So when you create a challenge, you build around something you know. So you will find that all my challenges are either using symmetric encryption, either using XOR or cryptography tools, because this is how I think. So this comes from a passion, basically. You must read some books, you must study everything about, let's say, reverse engineering. If you want to do malware, you must know how to work with reverse engineering. I'm still learning this. So it's a lot of work, and I can say that up until 6 months ago, I didn't know anything about RF. So working with one of our guys, which was expert to that, we managed to create a challenge in order to have it here. So basically, you must learn, you must use some competent resources, and you can create challenges. You will see how good they are. Let's say you can put it even on the web and submit answers. I don't know.
All right, let's take another one.
All right.
Sorry.
So anytime during a CTF contest, have you found yourself a challenge breaking up and you had to fix it during the live contest?
Like I told you before, we had the situation where the exploit rendered the system unusable and we need to perform restarts. So basically, the challenge broke, but this was like not under our control. We cannot modify the RDP.
All right, thank you.
Thank you.
And another one? There, right there.
There are 4 also.
In my experience, I have more experience with programming
Yeah.
contests and programming type of questions. And I've noticed that there are, in many CTF challenges, there's a section called programming. Are there any major differences between the normal programming contest problems and those that are in the programming section in the CTF contests?
I wouldn't say that in a program CTF, this is not my field, but I presume that being focused on programming, it's more like about the programming language. But in what we are doing, it's a lot of programming, because let's say if you do a cryptographic algorithm, that one cannot be calculated by hand. So you need to use a lot of, I don't know, maybe Python, maybe C, whatever suits you, but you need to use programming in order to get to the results. And you need to know exactly what you must do, because there are a lot of bitwise operation, or I don't know, functions, math implementation, stuff like that. So I think they would be the same with the fact that maybe in the programming it's more focused on the theoretical programming. Okay, thank you.
Are there any more questions?
In what degree these scenarios for challenges are in line or aligned with business scenarios? Because we know IT support business, so all vulnerability that impact negative business should be considered.
So I can tell you, okay, if I got this correct, one of the exercises, I was talking about to you about those server-client exercise. It was like a client connecting to an SQL server and getting some data out of it. And the hacker was in the network. It cannot compromise none of the systems, but using vulnerability in the Windows side and in the MySQL side, he managed to extract the password, which is in a file on a client, and building a rogue MySQL, had the password, connect to the SQL server, extract data. So business-wise, you would have all your data exposed to a hacker, so it's applicable.
One more question. There was someone over there.
Mai sunt 2 sau 3.
Okay. I had the opportunity with my company to organize a couple of Jeopardy CTF. Especially at the beginning, we were almost amateurs, so I mean, really basic stuff. During our first CTF, there was one challenge in which we completely forget about one thing. We made a big mistake, and so the solution was really, really, really easier than what we thought. In a similar case, what do you think would be the best move? I mean, we had a great discussion between people that wanted to say, we leave that, I mean, it's done, so it will be there, and other people that just wanted to take it back, fix it, and put it back online. What would you suggest?
It depends, but I would say move on, because if it was your fault, it was your fault. Basically, they found the flag. There was a solution which you did not foresee, but it depends, because if, let's say, they are close to the solution, but they did not solve it, and they come to you and ask, okay, this is how I should do, and you realize this before they solve the problem, you can change it.
No, it was too late.
When it's too late, it's too late.
Actually, we leave it like that. It was too bad. But
That's it.
thank you anyway.
Thank you.
Are there any more questions?
I've seen a hand over there. And the
Thank you.
gentleman.
Thank you very much for the very nice presentation. For me, it was quite enjoyable and interesting to understand how the CTF creators thinks and doing the stuff. Because I'm a CTF participant in Hack the Box, yes, Vuln Hub, and other stuff. Do you have any public accessible challenges?
No, we do not have yet. We have a public challenge which is here, but
Except the IoT.
no, we do not have public challenges since, like I told you, this is a business which is right now growing. We entered the CTF challenge creation last year, so we are improving, and we will probably at the next contest, which will, European Cybersecurity Challenge of the next year, we will probably have online challenges to train, let's say, the guys, the kids, who want to participate.
Okay, thank you very much.
Thank you very much for your presentation.
Thank you.